It was my understanding there was lots of inexperience with Excel as I was walking through the class as we were doing this in-class problem. So what I wanted to do was kind of walk through and essentially solve this on Excel. So those of you that don't have much experience can see the logic behind how to set this up and the tools to do this. And so this hopefully will get you started with increasing your background knowledge related to Excel. We're going to be using Excel a lot this semester. So we have our problem here. We're looking at a tank to reach 10% of the 32 milligrams per liter non-steady state conditions. We integrated it. These are just a snippet from my lecture notes from our previous class. And we came up with this equation: concentration at time is equal to 32 milligrams per liter initial concentration, or C naught, e to the minus 0.316 t to the day, or t over day or time. And your goal or your objective was to graph like this and find out where 10% of that concentration, or how long that occurred for 10% of that concentration to occur. So we've got our initial concentration is here, 32 milligrams per liter. We're going to reference this cell as we do our calculation. I ask you to essentially solve for time up to 10 days at a 0.1 interval. So we got 0, and I'm going to put 0.1, 0.2, that's here. And let's copy and paste, or copy this down so we can get 10 days of this data. Got 9. Let's just go a little bit more here so we can get 10. So 10 days, it's there. We can increase so we've got our significant digits that are consistent. And then for the calculation, it looks like I've already got this solved here. So we've got essentially, let's click on this here again. So we're referencing 32 milligrams per liter, which is this part of the equation. I got the F4, or function 4 is used, so you can get $, so that as we copy and paste that formula down, this part of the formula does not change, and so it references that cell continuously, times E, so EXP, brackets, is negative 0.316, times T. Now time is on this cell, which is C36. No $signs on this one, so that will copy and paste and travel down as we take that formula down. Click enter, and we got a concentration of 32 milligrams per liter would be our initial concentration. So it looks like this has been calculated correctly. Now I'm going to drag this down all the way to 10 days, and we've got it calculated. And so if we're looking for the time when we get 3.2, just visually here, it looks like it's about between 7.2 and 7.3 days. Next step is to plot this. So we're trying to get a graph that looks like this. Let's go ahead and highlight these cells here. And we're just looking for a standard XY scatter graph. So let's go to Insert, click on Charts here, and it looks like it's already got it selected. Recommended chart is a scatter one, so it's an XY one. We can click on that, hit OK. So there we have our chart that's right here, and it looks like it is correct. We've got all our data points that are on there. So now let's get our axes labeled. So we've got this axis. Let's go ahead and change those significant digits. So we can look at axis options. So where's that at? Let's see here. Text options, that's it. Nope, axis options. And let's click on here. And we want, alright, so we're going to look at these labels, and here we go with our numbers. At the bottom here, let's make that 1 decimal place. Change that. Now we've got to add our axes that are on here. And so let's turn that on, hit this plus sign, do axis title, make that correct. Alright, and so now we can change that axis title. And so this would be concentration. And put our units, milligrams per liter. So that would be on our y-axis. Whoops, we don't have to hit enter there. And this one, let's make this equal to time days. That that's there. And we could either type in a chart title. I typically just delete those unless I've got a bunch of multiple ones that are there. And that's what I'm looking for. And so that's the graph, standard XY scattered graph for this problem. And so essentially, again, it's solving or taking this equation and solving it and creating a graph that looks like that.